Hello guys, good day. We already finished the learning session 5 in our project construction and management subject. Now we will continue on learning session 6, which is entitled the network diagram. Okay, so actually we are more than halfway in our learning sessions. Okay, so if we check our learning session contents, we are now on, okay, let's go to our presentation. We are now on the network diagram 6. So we are now on learning session 6. Then 3 more learning sessions to go to complete the entire subject. Okay, so let's go to learning session 6, that is slide 133. When I opened that one a while ago, so this one. Okay, so we are now on learning session 6, the network diagram. Okay, so in our previous 6 sessions, we I introduce you guys to the network fundamentals. Okay, so in that learning session, you know what is critical path, what what are the rules in um, converting a certain tabulated data into a precedence diagram. Okay, so remember that all of that things are the tools in project management. Okay, so when you are working in a project, that's the main tool that we need to know as a civil engineer. So not only civil engineer but other technical uh, personnel on a certain project. Okay, let's go on to our discussions. Sorry. Okay, so for the introduction of the network diagram, every project is composed of works, activities, tasks, or functions that are related one or the other in some manner. Okay, so let us say example guys, if we are on the activity of concrete pouring. Okay, so remember that before you can pour a certain concrete structure, you need what you call a form work activity on that. Okay, so form works, the preparation of form works, the preparation of steel works, and other activities related to complete the concrete works. Okay, so that's the relationship of every task. Okay, then the main goal is to finish the project under the following objectives. Okay, letter A is to complete the project at the earliest minimum time. Okay, so what is it in a project to complete in a minimum time? Okay, so basically to reduce the cost. Okay, so remember that one of the golden rule of a civil engineer, guys, is always economical. Okay, so that's one reason why when we are doing our designs, we need to consider the safety and economical of a certain project. Okay? So letter B, to use any available manpower, equipment, and other resources. Okay? Okay, so this is very important, especially on those companies which have limited equipment and other resources. So you have to plan well your activities for that one. Remember that in some projects, they always say that use the available resources. Okay, so letter C. Okay, so for letter C, to complete the project with minimum capital investment without causing undue delay. Okay, so that is why if you are working in the construction industry, the manager is always looking on the cost. Okay, so he he will find a way to reduce the cost at a reasonable scheme. Okay, so example, we in saving electricity. Okay, so that's one example. You want to save electricity, fuel, so you have to plan for that scheme. Okay, so next, per CPM, per CPM is almost same. Utilize all resources effectively as possible. Okay, then time is considered as the controlling factor in construction management. Then time versus number of manpower, then time versus number of equipment, and time versus piso or money. Okay? So that's the controlling factor in construction management. Okay, so time. So you need to be good in time, or let us say to know how to deliver the work on time and to use that one uh, with balance to the number of manpower, number of equipment, and your financial capabilities. Okay. Next, we have planning and scheduling. So this is very important in a project. Planning is a logical sequence of the job to be performed. Okay, so in every start of the project, planning and scheduling is the first activity that all concerned employees and other technical personnel needs to do. Okay. Then we have the project manager's objective in planning are as follows. Okay, so these are the things that your project managers need to know. Okay, so that is his objective. Okay, so number one, to present graphically the specific job and a proper sequence of the job. Okay, so imagine guys, if you have a project manager who don't know how to do this. Okay, so how to manage your activities. So imagine what will happen to your project. Maybe that project will not be completed. Okay? And number two, you have to establish a medium for estimating the time, manpower, or other resources necessary for each job. Okay? Then number three, you have to have available sequential arrangement of the jobs. Okay, so an accurate estimate of resources and alternative plans based on scope of work. Okay, scope of work meaning that's the task or activities that you need to complete as per your contract to the owner. Okay, so you need to know your scope of work. Then we have scheduling is only secondary to planning, but it is the process of allocating calendar dates to jobs based on the approved plan. Okay? So meaning if you develop a certain plan, you need that one to submit to the owner to be approved. Okay? So that you have a mutual understanding or it as a objective or vision on the project. Okay, so we have now the definition of terms which are used in this learning sessions. One is critical path, which I mentioned in our previous learning session. A critical path is the longest route in the network of activities representing a project. Okay. Then we have the earliest event. Okay, so this event is the earliest time occurrences on the event, sometimes called earliest event time or early event time. Okay. Then we have earliest start. Okay, so this is an activity that cannot be earlier than the earliest event time of the event. Okay, ES or earliest start. Then we have earliest finish. This is equal to its earliest start plus duration of time. So meaning, if we formulate this one, earliest finish is equal to ES plus the duration or the activity, or you can have early event plus the duration. Okay? The next term is the latest event. Latest event is the latest time, the time may occur without delaying project completion. Okay? Then we have latest finish. Is an activity cannot be later than the latest event. Okay, so so the latest start plus duration is equals to the latest finish. Okay, so this is the formula for that one. L is plus D is equal to LF, or LS is equal to LF or latest finish minus the D or the duration. Okay, so duration meaning the duration of the activity. Okay, or the task. Then we have total float or total slack. Okay, so this is defined as the span of time an activity can be delayed after its earliest time without delaying the project completion. Okay, so this is the total float or total slack. Okay, so total float can be solved by these formulas. So latest finish minus the earliest finish, okay, or EF. Okay, or you can have LS, so latest start plus the duration, subtract that one to AS plus D or earliest start plus the duration. Or we have another formula, LS minus ES equal to total flow or latest start minus earliest start. Okay, so that is total flow. Okay, now we have free float. Okay, so what is free float? Free float is the span of time an activity can be delayed after its early start without delaying the early start of any succeeding actual activity. Okay, so the formula for FF or free float is equal to ES minus ES plus the duration or D. Okay, now we are on the independent float. Independent float is defined as the portion of the activity's free float that would remain if all its preceding activities use up all their float. Okay, so this is the formula. IF is equal to ES or earliest start minus latest finish minus the duration. Okay, please remember the formulas because this is very useful in solving problems related to PERT diagram or PERT CPM diagram. Then we have computing the early start and the early finish. Okay, so this is the rules in how in computing these items. Okay, rule number one: the earliest finish or EF for any activity is equal to its earliest starting time plus its expected duration time. Meaning, earliest finish or EF is equal to ES plus T. Okay, then rule number two, for nodes with one entering arrows, ES for activities at such node is equal to EF of the following arrow. For nodes with multiple entering arrows, the ES for activities leaving such node is equal to the largest EF. Okay? Okay, so let's try this example. Actually, I already prepared this one on the presentation and I will just explain this one verbally. Okay, so no need to compute to our magic whiteboard, okay, which answers everything. Okay, so this is the diagram that we need to compute the value of the ES and EF, meaning ES is earliest start and the earliest finish. Okay, so this is the diagram. So we have start. This is node 1 to 3, node 1 to 2. So this is the starting activities. We have 10 days for 1 to 2 and 6 days for 1 to 3. Then after that one, 2 to 4 follows. And another activity followed by 2 is 30. Okay, so 13 to 5, 2 to 5, then 5 to 6. Okay, so let's solve this one. Assume an early start ES 0. Okay, so this one for activities without predecessors. Okay, so this activity has no predecessors. Activity 1 to 2 and activity 1 to 3. Okay. Okay, so the earliest finish 1 to 2, so meaning 0, so plus 10. Then the 1 to 3 is 0 plus 6. Okay, so the early finish EF for activity 1 to 2 becomes the ES for the two activities 2 to 4 and 2 to 5. Okay? Okay, similarly, the EF of activity 1 to 3 becomes the ES for activity 3 to 5. Therefore, the early start for 2 to 4 is 10. Okay, so then the early start for 2 to 5 is 10 also. Okay, then for ES, the early start for 3 to 5 is 6. Okay, so let's go back to this one. Okay, so the early start for 2 to 4 and 2 to 5 is 10. Then the early start for 3 to 5 is 6. So because we just add the 0 plus 6 and 0 plus 10, then for this one, this is now the earliest start for these two activities. Then for this activity, the earliest start is 6. Okay? Okay, so then the corresponding time for these activities are, so for ES 2 to 4 is 10 plus 8 is equal to 18. Then 2 to 5, 10 plus 13 is 23. So let's check. 10 plus 8, 18. Then 10 plus 13, 23. Okay. So this is now the earliest start for this activity. Okay, so let's check. Okay, so for AS 3 to 5, 6 plus 12. Okay, so now that's 18. So let's check. 6 plus 12. Okay, so 18. Okay, so In node 5, you notice that we have 3 now early start. Okay, so 18 for E is 4 to 5, that is 18 plus 24, 18 plus 4 to 5. Okay, so this one 18 plus 4, 22. Okay, so the activity 4 to 5 has an early starting time ES equal to EF 2 to 4 18, an early finish time of 18 plus 4 22. Okay, so activity 5 to 6 with the three predecessors has an early starting time ES equal to 18, 22, and 23. Okay, so that's what I explained a while ago. So this one, activity 5 to 6 has three predecessors. Okay, activity 3 to 5, activity 2 to 5, and activity 4 to 5. Okay, then the number of days for that 3 is 22, 23, and 10. Okay, so let's see what happens next. Okay, so select the largest number, which is 23 plus duration to 25. So the early finish for this project is 25 days. So just choose the highest figure among the three, then add that one to the duration here of 5 to 6. Then this is the day, the number of days for the earliest finish of the project, meaning 25 days, the earliest completion of the project. Okay, earliest finish or earliest completion. Okay, okay, so this is the summary of the table. So 1 to 2, the duration is 10. ES is 0 because without predecessor, we assume that the ES is 0. Then the earliest finish for this one is 10. For 1 to 3, the duration is 6. Then since this activity has no predecessor, then the ES is 0. Then 0 plus 6 is 6. Okay? So for activity 2 to 4, the duration is 8. Then the earliest start now for this one is 10. Okay? So because they are connected, so 10. Then the earliest finish for the 2 to 4 is 8 plus 2, 18. Then for 2 to 5, we have the duration for this activity is 13. Then the ES or the earliest start of 2 to 5 because this is the source. So 10. Then 13 plus 10 is 23. Okay, next is 3 to 5. The duration is 12. Then the ES is 6 because it follows to number 3. So this one is the duration. Then the ES is 6. So 12 plus 6 is 18. Then 4 to 5. The duration of this activity is 4. Then the ES or earliest start for this one is now 18 because 4 follows 4 to 5. Then 4 plus 18 is 22. Now for activity 5 to 6, the duration is 2. Then the ES for this one is 23 because 4 to 5, for 2 to 5 is 23. Okay? For this one, remember that for this 3, we need to choose the highest figure or the highest number of days. So that is the ES for this 5 to 6, 23. Then let's add that one to the duration. Then 22 plus 2 is now 25. So meaning 25 days is the completion of the project based on earliest start and earliest finish. Okay? So that's it for ES. Okay, so now guys, let's try computing the LS and LF, meaning the last start and the last finish. Okay, so for this project, we already computed the ES and EF. So this is the source or this is the a diagram that we need to use for that one. For this ILS and ILF. Okay. Okay, so for this one, we just need to track back our computation. Okay. So example, this one, 25, this is the earliest finish for this project. So we just need to subtract. So 25 minus 2. Okay, so let's see the table. So 25 minus 2 is the latest start is now 23 for activity 6. Okay, so this one. So 23. Then going backward again, so we need to subtract 23 to 4. So this is 19. Okay. Then 23 to 13, 10. Then 23 to 12, 11. Okay, so you notice guys that activity 2 to 4 has two activities on it. So for this one, 23 minus 4 is 19, then 19 minus 8 is 11. So since this node has to latest uh, start, latest finish, so we need to use the lower or the lowest figure now for this time. Is the lowest figure for this node is 10. So we need to subtract 10 to the duration. So the answer now is 0. Okay. So for this path, 11, then 11, 5 minus 12. Sorry, 5 minus, sorry, 23 minus 12 is 11. And 11 minus 6 is 5. Okay. So for that activity, so let's check the table for this one. Okay. So that one. So the latest finish for this one is 5 days. Okay. I think that's all. Let's see what's next. Okay. So this is the summary of the computation, the tabulated summary. Okay, so I think this is it guys for the part 1 of learning session 6. We are now almost on the 30 minutes mark. If we check the time, it's already 28 minutes. So I think that's for now. That's all guys. So this is part 1 of learning session 6, the network diagram. Okay, so for our next video, we will continue on the solving the float or slack time. Okay, so I hope you learned something on what I discussed and I shared to you. And keep watching and learning from my videos, the Ininyong Cowboy YouTube channel. And please share this one to our fellow to your fellow engineering students who wants to learn engineering subjects. Okay, then don't forget also to subscribe to this channel and click the bell the bell button so that you will be notified in times that I will upload new videos. Okay, I think that's all guys. Thank you for supporting my channel and see you soon on the next part of this learning session. Thank you.